Hi, welcome to the second tutorial on NX Motion. Today I'm gonna prepare this excavator for motion simulation. So basically what I want to do is to add constraints, not because I need to read them in the motion analysis, but because when I go back to modeling, I want to be able to move it around. I will talk about that more when we move it to the motion. So first, so since you asked me to talk more, I'm gonna talk a lot. So here I'm gonna turn off the PMI objects, these stuff on the screen, and I will start from the bucket, moving up, and then after it's finished, I can add pins as well. So first, let's see how we can connect them. Well, let's start from here, the bucket. So move to assembly and start with assembly constraint. I'm gonna go with cylindrical first, and then I may use hinge as well or centering, but cylindrical will be enough for now. So let's go with in a cylindrical constraint. You should be able to do it without assigning a point, but in NX you need to assign a point and a vector, which doesn't make any sense, but anyway, just make sure that the vectors are in the same direction, otherwise it's gonna flip your connection. And the next one is here, check the vectors, and okay. Here, the and remember, if you don't click apply, nothing happens. It won't save your constraint. So be careful. If you miss something or do some mistake, you have to go back again and do it from the beginning. So I'm gonna click on apply now and then, like this. So we're good up to this point. I have to do it. This side is connected, but this link is not constraint anywhere. So I'm gonna constraint this one as well. If you zoom back, it's easier to see the vector directions if they match or not. So this seems okay. And let's also add a constraint here before I move to the slider constraint. Here you see that the vectors are not in the same direction, so I just flip one of the vectors and that will fix it. And then we have this one. Again, I need to flip the vector. And for this one, Here I don't want this connection, and I think this will move all the way to the back. So I hit Control Z, and first I bound uh, these elements. Here I have a filter. I have to select no filter, so I can select my components. I want to connect all of them before I do anything because I want them to move together. They're already in a correct position, and I bound them. So this is a kind of bounding constraint. And now I can go back to cylindrical constraint. Now you see everything is moving together. That's okay. At the end, we're gonna have the whole excavator moving a little bit forward, so everything matches perfectly, which is okay. Now we can do this one. Also down here. Vectors are not matching, so I need to flip one vector. And I think the last one is this one. And this is not necessary, I guess, but let's have it. If it will show if there is any problem. So okay, there is no problem. So far so good. But remember, this is just a cylindrical connection, so it can slide actually, unless we fix them and center them, which I'm gonna do later. But first, let's make a slider for these. We have 4 connections. We need to use a slider. Here, I choose a slider. For the slider, the point does matter. So we need to, no, even for the slider, because it's some kind of a cylindrical connection, doesn't matter where you select the point. Here, I can choose anything. But the direction of the vectors should match. So here, for example, doesn't match. I flip one and it should be okay. Next one is here to this one here. See, they don't match. Okay, now it's good. And this one. I forgot to fix it, and that's a problem. You can use Control Z and do it again, or you can click OK and go to the constraints and find that one. Go to redefine and then flip one of the vectors that was wrong. It seems correct here though, but let's see. Yep, now it is correct. so I can move to the next one. They don't match, so I flip the vector and done. Now every now and then you can select and click on move on the bucket or anywhere else and move the thing around to see what is actually not connected. So here this one is not connected. I have to fix this before moving on, or I can, yeah, so we have this cylindrical. These holes are good references. I can just fix this and it will move sideways as well, as you can see. So I'm gonna fix that too, but for now, and this one is also missing the connection. So let's just start from here. I'm gonna cancel this and it's going back to the place it was. You can also move the component that you think it's having a problem to check, but you need to be on the assembly level. But this has its own assembly, so I'm not gonna move it around. Let's try again with the bucket. Yeah, I forgot to fix the, let's fix this first. So I go to assembly constraint and I select the fix constraint. I want to, here I put it on no selection filter and I fix this, and you see the ground icon, which means that it is fixed now. Now we can move the bucket again and see the reaction. Yeah, I can keep it somewhere around here, so this way it is easier to access the connections that I want to fix. Going back to cylindrical again, to fix it to this red part. Let's check the vectors. They are matching, so it's okay now. And we have two more here. Vectors are good. And this one, it doesn't matter where exactly you put the constraint. We just want to confirm the motion. So later on, when we want to move this around and do a new motion simulation based on the new position, it would be easier for us. Let's move the bucket again and see if everything is correct. Yep, it seems good, except that it can still move sideways. This could be fixed by centering everything. So again, I will go from this way this time. I need to cancel this. So it goes back to the same position it was. Click on assembly constraint and this time go with the center. I select 2 to 2. This will put two faces in the center of another two faces. Like I want to put these two between these two. Nothing happens because it was already in the center. So that's okay. Can click apply. Then I need more on the here we can have one. So these two stay on the center of these. Apply, and we can do one on the bucket, and then check if we need more or not. All right, let's check. Yeah, the bucket moves with the top part, and yeah, so we need a lot of centering. This one. You can also go with the other constraint like concentric constraint and like connect these two edges, but I'm not sure if there is a clearance here or not. And maybe later we want to come back and have a clearance. So it's better to use centering, because if I use concentric here and later on I change the thickness of this one to apply some clearance, it will go and attach to this side again. It won't stay in the center, but I want it to be in the center. So let's continue with the centering. This part should be in the center of this one. And this should remain in the center of this one. Let's check it out. Here we are okay. I don't know if we have problem somewhere else. I will check that too. But it seems okay now. So we can move it around and see if there. We could put limits here. It doesn't matter for now. Uh, that problem will be solved in the motion simulation. Let's go back, and then I will start now to make pins. So let's save everything and move to making pins. Now, to make pins, I need to measure dimensions on each joint. So first, move to view. I want to hide the constraints so I see what's going on. Then click on measure here, and we can continue measuring. But if you don't have it here, if you don't have this icon here, don't panic. Right click here, and this is, I think, top border bar. Go to customize, and here you can add anything you want anywhere you want. So type the command that you need, like measure, and then drag and drop it wherever you want. I don't know, you can put it anywhere. I think it should be on the tools, but I need it here, so now I have to. So I can right click and remove from top. Let's go back to home. So now I can start measuring. Click on the measure tool, make sure it's on the object, and I start from here. I need the diameter, and I need to keep the information. So if you go here to the setting, you can click this, which keeps this annotation on the screen. Click OK. You see this information about that particular hole. I also need the length from here to here. So the minimum distance here, 900. And I click apply, it stays there. Now I can, this one is all probably the same. Let's measure this. This is probably wrong, this distance. We probably need to fix this before moving on. Yes, here this is going inside. I need to go back and move this out if possible. Yep. So here we better go with the constraint to set the distance. This is a result of moving it around, moving the excavator around, and that messed with some locations. Here we need to go with distance constraint, and we want this from here. I assume it was 900. But it seems I don't know if I still have a problem, but it seems that it's fixed. If I use Control Z, yeah, and Control Y, yes, so that one is fixed. So here 900, they are all 900 millimeters. Let's check the diameter. If the diameter is also same, this is 90 or 180. Same here. Yeah, they all seem same size. So we only need to make one pin. Let's say, yeah. So we move to new component. Here, I select the model template, make a name. Let's say 900 by 180. Let's say, or we can go with the radius. It's okay. Click OK and go to the Home tab. Click on a sketch. Sorry, first we need to go back and make the pin as the work part. Then click on a sketch. Select the coordinate system and a plane that you want to work on and click OK. So the radius was 900 or diameter 180. Click finish, hit X or click on extrude, same thing, doesn't matter. And 900 length. Direction, location, and position of the pin doesn't matter. We're gonna move it to the right place when it's finished. Now this one is finished. I go back to the assembly level and then right click here and copy. You can also do Control C, Control V and then paste it on the assembly. Now you see I have two. Do it again, get three, and again now I have four pins of the same size. Now I position them. I go to assembly constraint. Here I can use hinge because I can actually fix it on one side. By using this, I don't need to use centering anymore. Because for a pin, if there is a little bit of a pin out of the system, it doesn't matter. That's fine. So I go with the hinge. For the hinge, we actually need to specify points. I mean, you need to specify points for a slider and cylindrical as well, but points are important here on the hinge because the points are going to match together. I want it to be on this vector and this point. So I check the vectors first. They should be the same direction. Better to be on the other direction, but it doesn't matter. And the points is here and here. I click create join. So one of the pins jumped here. Take the other side. It is correct. Let's move to the next one. Vector, point, and here the vector and the point. Check the direction of the vector. One needs to flip, and it's fine. Next one. Check the vector. And the last one of this side. Here. Okay. So we got 4 pins in place. Next, let's measure this one. This is a 70. Let's see if, unfortunately, it doesn't keep the changes. I have to check this again. But anyway, this is 70. I apply to keep it. The length should be from here to here, which is 425. Click OK. It will remain on the screen. So let's do the next one as well. Maybe they are the same size, so we make only one pin. Okay, so it's 420. It's not the same size, but since we are here, let's measure the diameter too. Diameter is also different. It's 80. Click OK to keep the information on the screen and move to new component. I want to make a new pin. This one is going to be 425 by 70. Click OK and OK, and then make double click on the part you just made to make it as a work part. Otherwise you start to draw on the assembly level and that's a mess. Now move to home and click on a sketch. Select the plane you want to start your sketching. It doesn't matter what you select, as I said. So this was 70 or 140 by 425, I think. We can change it later, it doesn't matter. And move back to the assembly level. Let's constraint it with a hinge, vector, point. Here is my vector and point on this side. Check the directions. They are matching. Click OK. Yeah, this is fixed. The next one is 420 by 80. New component. Pin 420 by 80. OK. Select the new part. Start a sketch and the plane you like. Click OK. Start with a circle. 160. The diameter was 80. The radius was 80, so the diameter is going to be 160. And the length is 420. And click OK. So we're gonna continue the same thing for making pins. I go to assembly constraint. It's on hinge. I'm gonna hinge it here at this point. Check the vectors, need to flip and click create join. This one is finished. Move to the next one. First I need to measure it from here. So here 800 and the diameter is 87.5. So new component here, pin length was 800, I guess, and 87.5 if I'm not wrong. Yes, it's 800. Select the work part, the new part as the work part. Go to home, sketch, select the plane, start with a circle, go 87.5 multiplied by 2 and click. Sorry, I made 2. Click finish and extrude. This one was 800. So we're gonna repeat same thing for the rest of the pins. Assembly constraint, make a hinge here. Make sure the vectors are correct and create join. This one is okay. This one doesn't need a pin. But it seems we need to change the dimensions a little bit because there is no clearance here. I can fix it now. So I double click on the part. I go here to the part navigator. The extrude that I'm looking for is this one, I guess. Yeah, it's the other side and it's mirrored at the end. So it's now 50, which is enough on the other side, but let's make it. This is for the end part, not the. So probably this one. Yeah. Let's make it 210 or 220. No, 215 seems to be good. Something. Yeah, this seems to be fine. So now it will change everything, center everything, fix everything again, and comes back here. So yeah, the problem is that here we did not center this one. So that's the problem. And I guess this one will move if I, yeah. Also the assembly I think will move. they will move together because they are both part of the same assembly. So the best way to do it is to move them, but for now I'm gonna keep it this way because let's see, we can actually unpack it and move them around. But they're not in the same assembly, so that will make it a little bit difficult. Unless I just move them out of the assembly. So let's unpack these two as well. So this set is with this set. Let's see if we can move them. Yeah, it seems that it is constrained to the other one. Here we seem to have a problem as well. So let's start from here and see if we need to center them. Yes, the problem starts from here, probably. Yeah, I don't have much problem here, but here we have a problem. So this is the piston. Let's see if we can move it. Or we can just center it. That will work better with a centering constraint. Since I don't have access to that part, it's going to be a little bit harder, but that's fine. So I go with the center. We just select this side. This should be between these two. Now it's okay. That should fix this part as well. Yes, this is now centered, but this one is not. So going to move this one. Let's see if moving is possible. Yeah, we can move that individually. For now, I'm not gonna center it because it's okay. We probably don't define contact, so I can leave it here as long as there is a clearance. But you can also center that one as well. Now going back to making pins, we finished this one. Let's save before we move. Next pin is here. Let's measure it from here to this point. I don't have a measurement. Let's see what's the problem. Okay. 480. And the radius is 80. So 480 by 80, I make a new component. Pin 180 by 80. I don't think we had this size, but I'm gonna make a new one anyway. Yeah, no, we don't have it. Home, sketch, select your plane. 160. Finish. And 480. Back to the assembly level. Assembly constraint. Hinge. Select the vector and a point on the pin, and then on the joint. Check the vectors. They are good. Create the joint. I don't need a pin connection here. There is already a pin connected. The next one is here. I think they are the same size. So let's see. This is 125 and the length of the pin is 520. New component, pin 520, 125. Select the new component you made, sketch, select the plane, was 125, so 250 by, I remember, what was it, 520. Extrude 520. We got a new pin. Move the assemblies. First, let's move up in the assembly, then constraint, and make a new hinge. Here and here. Check the vectors are not okay. Flip one, and there you go. Should have copied it first, but it's okay. Just right click, copy, right click on the assembly level, and paste. Now we have to, just to make sure I'm not moving or the constraint one. I'm gonna right click here, unpack it, and you see one is not constraint. The this one, this half black one is and if you don't have this column, don't panic. Here you can right click, go to columns, and click on positions. So it will show you which part is constraint and which is not. So we can see here, for example, what we need to do next. These are the things that we need to fix next. But for now, let's move back to this one. And let's fix this. I'm gonna move it out a little bit so it's easier to work with. And then constrain it. From here at this point to this point. Check the vectors. This one is going to flip and finished. So this is almost done. I just need to check it again. If the pins are constrained correctly. Yeah, all movements that I need are correct. Cancel and let's save it. This save all will save all the parts, whatever change you made. Now I can look here and constrain things that are not still constrained. Starting from this one, this part needs to be fixed to this part. So I can go with bound connection here. I'm gonna connect this, but I don't want to connect it. We're not, yeah, it's okay. We can connect it all to this part because I'm not going to roll the wheels in the modeling, so we can connect it. And this should be connected here. And that's it. The rest I'm gonna, let's see, we had a ground connection here. I need to remove that. If I go to constraint, you can just uncheck it or completely remove it. Doesn't matter. We don't need it for now because I want to move this up to make a new constraint. So let's move it up because it's easier to work this way. But let's move everything together so we don't have positioning problem. And I think I have, yeah, I have access here. So I can have a cylindrical connection here. Inside this. And then I can also have a distance connection. That I think will solve the problem of rotating this thing. So let's first bond these two. It's on the bonding. So this one. I thought we already bonded these three, so those two are okay. And then a cylindrical connection here between this and here. Just make sure the vectors are same direction and create the join. Yeah, it moved a little bit to match the vectors. And also we need to fix the distance so this won't fall while rotating. So whatever distance it is probably okay. I'm gonna have a distance from here. Let's say to this point. Doesn't matter. It should be to some reference. And this distance is okay, whatever it is. Don't change. And then let's try moving around. This side is okay, but I don't think it will turn. Yeah, we still don't have turning yet. So let's see what's the problem. Yeah, the problem is with the probably the superstructure. Or we can try turning the bearing part, see if that helps. Yeah, so we have this part as well, but as you can see, this here, we don't have this connection yet. So seems that I have to fix them before moving to the motion analysis. I have an easier access here, so I'm going to fix it here. Assembly constraint, I want to center them 2 by 2. To center these two, between these two, and the same thing here. Okay. This changes. This changed the position on top here. We probably have interference. Yeah, I'm gonna go back and fix that. But for now, seems okay. Now let's fix this since we're already here. Just need to make this part a little bit smaller. So let's move to the part navigator. This extrude is here. It says 80, let's go with 75 maybe. Yeah, seems good. Let's see if the problem is fixed. Yeah, but on this side, we still have problem. So I think there is also a problem with the mirror plane. It seems okay, but for now I'm just gonna make it a smaller so solve the problem for the other side. This should fix it, yes. And also make this a little bit longer, maybe 220. So I don't need to be worried about the clearance in that part. And I want to just check the plane if it's in the center. Yeah, the plane seems to be okay. But that's fine. We can go back anytime and fix this. Now let's move back to the main assembly. Let's take a look if everything is fine. Of course, except these two. There is a bit of clearance here, so that's fine. But at the end, this needs to be fixed. So we need two more pins down here before we finish. Then I can actually center these two on the top because we have enough clearance here. Then we could move them these supports around, which that is going to be okay. But first, let's add the remaining pins. First measuring. This is a 70 by 520. Here we're gonna have a pin 520 by 70. Okay. Select the new part, go to home and sketch, pick the plane you want. Diameter is 140 and 520 is the length. Go back to the main assembly and duplicate by copy and pasting the pin. Move back to the assemblies, click on assembly constraint and select hinge. I'm gonna hinge this to this point. Let me check the vectors. That's fine. Next one. From here, check the vectors. This is finished. The only thing remaining is centering them. Go back here to find the centering. Yes, I have this. These two are the centerings for the bottom part of the actuators. So I'm gonna remove them and make two centerings for the top one. That will solve the problem we have here. Centering this, I don't have access to that part, but here I can select it actually. And I want it to be between this side and this side. Yeah, this is the correct one. Let's see if I can do the same thing here. These two sides should be centered. It's really hard to work unless you move it a little bit away, of course, and it'll be easier for you to select the stuff. Yeah, but this is okay. We can take a look. This one is centered, this one is centered. It is probably not perfectly in the center down here. I don't know if it's visible in front view. Yes, we need to move the whole support here a little bit away. That could be done here in the assembly, but you can do that. That's pretty easy task. All right, this is almost ready to be transferred to the motion simulation. But before we move it there, we can assign material. So if you go to tools and assign material, here on the assembly level, you can select anything, but I will select all bodies in the work part, so it selects everything. And I assign a steel for now, 4340. You can use another steel if you want to, or 304 is also okay. And then because we are only interested now in the mass of the system, later on we can choose different things like plastic or other things. But this is more conservative. If you consider plastic and glass as metal, it just gets heavier and that's more conservative. So let's go with that for now. But during the simulation, we can change the materials if we want. But since most materials are metal, it makes sense to uh, assign everything as metal. So to take this model to motion simulation, note that I also added a ground and I added the material so we can Basically, you can't take this to the motion now, but it's better to bring out and break these sub-assemblies. So in the motion simulation, it's easier to study the force in between these connections. So what I'm going to do is to move these assemblies out, the parts, this way, uh, but you need to make sure that you constraint them by using a bond connection like this. Now I'm gonna check the rest of the sub-assemblies as well. This one is fine. We actually don't even need those bolts, but it's okay, it can stay there. Pistons are fine. These two parts, we don't want to study the connection here. The left and right assembly, these need to be out. Probably, yeah, the assembly is now empty. We can remove it. And there is the motor assembly with a shaft and a gear. These two also need to go out. And again, the motor assembly is empty. We can remove it. So here, this is ready to be transferred. I think we also have this one, but the cabin and the base is okay. Only the hooks. We also want to study the connection between the hook and the rest of the structure. So that should go out. And the main bearing. Let's see the parts. Yes, the bolts are same. Yes, okay. We can save here and then move to the motion analysis. Here I make a new motion simulation. Can make a new name. Go with a component-based simulation, but I don't want to have the resort because it's easier to make the joints. And first, let's change the solver to recordine. Hide the ground, it's not needed now. To focus on the rest of it. So from here, I'm gonna make some parts, and so you know what's going on. Then I skip to the simulation. Here, start with defining motion bodies. For example, here, these two can act as one motion body plus the cabin, because we don't want to study the connection between them. It's okay if they act as a rigid body. And also with this connection, and this is fine. And you can also name it. Gonna apply. Now, so you can't select it again. That's that shows that the parts that you cannot select are already defined as a motion body. Next, I want the wheels to act as a pair. Same here. I'm probably going to rename some of these parts so it's easier to handle it. This part should be one motion body, also this part. And moving up, you have this part. I'm going to define the pins at the end so they are all in the same place. This also could be one motion body, but as I said, we want to study and see the results of forces between them, so that's why I'm doing it separately. Same here. Moving on, we have one part here. The cylinders and pistons, and yes, okay. So far, we don't have anything to select here. Okay. Remainings are this part. And the bucket. I think it's almost done, so I can move to the pins. I select all the pins and click apply. You see that it is generating a new name as I move. You should actually name them correctly so it's easier to work with them later on. But here I just want to demonstrate how to define the motion bodies. Also, if you go with the wizard, it will automatically bring all of them in and name them as the name of the parts in the modeling. So this seems fine. Yeah, it seems that we have some parts that are not on the assembly, so those are not added. I'm gonna check them later. Let's save here. Now if I select all here, we have 8 remaining objects. Here I forgot these two, so let's add them. It seems that we have a material problem here. So, yeah, no, it's correct. Can have it automatic. I think these two are this, and this should also be automatic. Probably the rest is okay. Yes. Let's check again. Got four more objects, which are these objects down here. So I don't want to work on them for now. We'll take care of them later. For now, let's bring back the ground. Here is the ground. I will change the color so it's easier to see. And select anything. Let's make it blue. And make a motion body. Automatic. Fix. Name it G. And we're good. Only have one joint for now, which is the fixed ground. So I'm going to do a couple of joints and leave the rest of it to you. First, let's do a slider joint. A joint, we need a slider. We want this motion body and the origin is not correct. I'm gonna get rid of the ground for now to navigate easier. And let's have the origin on the other side. And also the vector should be like this. And then the base, these two motion bodies are same. Okay. And the rest is okay. We don't want friction or driver for now. So this is how you make a slider. For the pins, we can use a revolute joint and cylindrical. The best practice here is to first fix the pins to the main body. For example, here, this is the main body, has a couple of fixed pins. So I'm going to go to the fixed and fix this to this pin. Sorry, I have to select this and fix it to this one. Or it's better to be the other way around. Let's do it again. Let's fix this pin. I'm gonna fix the vector. The origin is okay. The vector should be like this. Even though for fixed stuff, doesn't matter that much how you put the vectors. Then again, for example, this pin, the origin is okay. Vector along the length of the pin and to this motion body. So this pin is now fixed. If I now make a revolute, it will keep everything in place now. So I go to revolute. I want to do this motion body on this origin. The vector should be like this, or the other way, to this motion body. So the pin is fixed to this motion body, and there is a revolute connection to this part, and that will hold everything in place. And for the rest of them, for a lot of them, we only have fixed. So for example, this part is fixed to this part is fixed to this part. Everything that is well lit in place or has a bolt is going to be fixed. And after that, we can continue with doing some basic motion. So I think that's enough for this tutorial. See you on the next one while we are doing some motion analysis on this.